Hello, this is Deepthi. Now I'm going to implement fifth project of NAND2TETRIS. It's called computer architecture. In the previous projects, we have built the computer's basic program and storage devices. In this project, we'll put everything together, yielding the complete hack hardware platform. The result will be a general purpose computer that can run programs written in the hack machine language. The main objective of this project is to complete the construction of the hack CPU and hack hardware platform leading up to the topmost computer chip. Now I'm going to implement this project in hardware simulator. First, we have to load the chip with the program. Now you can see the program got loaded to the chip. Now we have to load ROM with rect file. We have to load the ROM with hack file. Now we have to set RAM 0 as 50. Now we have to run the program. Now you can clearly see the formation of rectangle here, which is the output of the program. The rect file that we have loaded here draws a rectangle of width 16 pixels and length RAM 0 at the top left of the screen. Now here is an interesting observation. Normally when you run a program on some computer and you don't get the desired result, you conclude the program is buggy. In our case, the supplied rect program is bug free. Thus, if running this program yields unexpected results, it means that the computer platform on which it runs is buggy. So this is the final output of NAND2TETRIS 5th project, which is computer architecture. Now I am going to implement 6th project of NAND2TETRIS, and it's called the assembler. The basic background of this project is low-level machine language programs are rarely written by humans. Typically, they are generated by compilers. Yet, human can inspect the translated code and learn important lessons about how to write the high-level programs better, in a way that avoids low-level pitfalls and exploits the underlying hardware better. One of the key players in the translation process is the assembler, a program designed to translate code written in a symbolic machine language into code written in a binary machine language. This project marks an exciting landmark in a NAND2TETRIS odyssey. It deals with building the first rung up of the software hierarchy, which will eventually end up in the construction of a compiler for Java-like high-level language. The main objective behind this project is writing an assembler program that translates program written in a symbolic hack assembly language to binary code that can execute on the hack hardware platform built in the previous projects. Now I am going to implement this project in assembler. First we have to load the source file, which is Pong. Now I am loading Pong file. Now I have to load comparison file, which is pong.hack. Now I am going to run the project. Now I am going to run the project. You can directly see the destination file, which is the converted file, which is converted hack file to binary file. Now this is the comparison file, which compares between destination and comparison file. Here there is a message called comparison succeeded, which comes when the two files, which is destination and comparison files, are equal. Now that we got the output here, we have to go to CPU emulator and run the same code. First we have to load the program, which is Pong Hack. I'm loading the program and I am putting this into no animation and I am putting it as fast and running the program. Now you can see the Pong game which I can play here. Oh, it's game over and I lost the game. But we got the correct output, which is the desired one. Now I'm going to implement project 7 of NAND2TETRIS. It's called Virtual Machine 1 Stack Arithmetic. The main objective of this project is to build a basic VM translator focusing on the implementation of VM language, stack, arithmetic and memory access commands. In project 8, the basic translator will be extended to full-scale VM translator. Now I'm going to implement this project in VM emulator. Now let me go to VM emulator. As you can see, the programs and script is already loaded, but still I'll show it to you again. First, we have to load the program. Basic test. Project 7 memory access and basic test. We have to load basic test.vm program, the chip. Now we have to load the script with basic test.tst. Now you can see that the full script got loaded. Now we have to run the program. This is the VM code that we have loaded, and this is the working stack. This is the virtual memory segments, and this is the global stack. These are the emulator controls which we can put it into decimal, hex or binary. This is the host RAM, and this is the script that we have loaded. Now I'm going to implement the same code in CPU emulator. First we have to go to CPU emulator and we have to load the program called basic test.asm, and we have to load the script. Now we have to run the program. As we can see that it is repeating for 600 times. It goes till 600th place of the ROM and stops. Now that we can see it got stopped here at 600, we can go to output window and we can look at the output. This is the allocation of RAM. We get the same output in VM emulator also. Now we'll go to 8th project of NAND2TETRIS. Now I'm going to implement 8th module of NAND2TETRIS, and it's called virtual. Sorry for that. Now I'm going to implement 8th project of NAND2TETRIS, and it's called Virtual Machine 2 Program Control. The main objective of this project is to extend the basic VM translator built in Project 7 into a full-scale VM translator. In particular, in Project 7, we focused on handling the stack, arithmetic and memory access commands of the VM language. We now turn to handle the VM language branching and function calling commands. Now I'm going to implement it in Virtual Machine Emulator. First, we have to load the chip with the program. Now I'm loading the program. First we have to go to 8th project, and the program I'm loading is Fibonacci series, which is there in program flow, Fibonacci series, and I have to load Fibonacci series.vm file. Now I have to load the script, which is Fibonacci series VM emulator.tst. Now I'm loading the script. Now that you can see the script has been loaded, now we have to run the program. Now you can see that the program is getting executed. As here it says that it repeats for 73 steps, it goes to 73 steps of the ROM. This is the working stack, this is the VM code, and this is the global stack. Now we can see the output of the program as 1011235, which is a Fibonacci series. We can also compare this with the compare file, which is same. The compare file is same as output, you can see it here. And here there is a message called comparison ended successfully, which means that this got executed successfully. Now we implement the same thing in CPU emulator. We have to do the same thing. We have to load the file called Fibonacci series.asm. Now we have to load the script, which is Fibonacci series.test. Now we have to run the program. As we can see that it is repeating for 1100 times. It takes a bit of time to execute. It goes till ROM 1100. Here you can see that. We can see that we got a message here. It's called comparison ended successfully, which means it got implemented successfully. We can see the output here 10111235, which is the Fibonacci series, and we can compare it with the compare file, which is also 011235. Until now I have implemented 8 projects of the NAND2TETRIS, which is 1, 2, 3, 4, 5, 6, 7, 8. For the implementation I have took reference from the official website of NAND2TETRIS. Thank you.